Good morning, dear students. Today we will discuss the next topic, the previous discussion session. Here, as you know, we are in second unit regarding we are discussing regarding pipe joints. Here, pipe joints are exclusively in this topic are used to connect pipes in water supply system. See here, so far we have seen almost 3 to 4 types of joints, and also we have seen how the pipelines will be laid in the ground and what are all the precautions that we must take during laying of pipelines. We have seen. See, when we go through a look of flowchart, what we discussed in the first unit, we have seen both surface water, groundwater. The surface water we have finished, groundwater we have finished. We have finished intake walks. See, this flowcharts gives the information about the syllabus or else about the supply of water from the source to consumer. We are here, intake was up to here, we have finished. There itself, in the work curriculum, one topic has mentioned with respect to pipes. In the pipes also there are different subtopics, types of pipes, pipe materials. Pipe materials in the sense we have seen the classification of pipes with respect to the material to which they are manufactured. And here we are discussing about various joints, types of joints as part of the curriculum. We are here, means we have finished 4 types of joints. Before that, we will discuss the specifications of the pipe joints or else desirable specifications of pipe joints before we are selecting them. See, for that, when we made an attempt to categorize those desirable features, we have seen all these 6 categories or 6 parameters: imperviousness, adhesiveness, durability, elasticity, availability, and the strength. Once the joints are fulfilled all these parameters, we may go for different types of joints that are available. And there, first one we have seen spigot joint. This is a spigot, and here one end of the pipe is kept into the spigot, and the other end of the pipe also introduced, and then it will be, it will be wrapped, whereas the pipe after fixing into the socket, that will be wrapped with tampon to avoid the leakage. And we have seen the basic, how it is functioning with the diagrams. I told you, you must sure or else you must confident enough about this of all these diagrams once you are preparing to write examinations, because so far in all the topics what we discussed there are diagrams. So you must learn the diagrams, then you can automatically write up. You learn automatically write up part, because without write up part you can't draw the diagrams. Once you are sure enough about these diagrams, automatically you can learn, automatically you can able to understand the concept behind the diagram. Screwed joints we have seen, the two pipes ends are kept near to each other and the joints are placed on the pipe. See here, the socket has the threads at inner side and the pipe has the threads at outside. Likewise, the joint will be finished. And collar joints we have seen, a rubber gasket is kept in between the pipes. Above the pipe, the 1:1 motor will be, cement motor will be placed. Just above the motor, the collar will be placed. So that is the reason we just name them as collar joints. And especially these types of joints are used to use for jointing concrete and asbestos pipes. See, our next one is flanger joint. See, this is the rubber ring, or is rubber gasket, and it is the bolt. See, the nuts will be played vital role to tighten the pipe, or else to make the joint more fit. See here, when the nuts are getting tight or making tight, automatically the joint will be closed tightly so that we can avoid the leakage. The expansion joints we have seen. Likewise, this is the next topic, flexible joint. Flexible joint in the sense, or else the other name of flexible joint is here, bell and socket. It is also called with another name, universal joint. See here, joint also can be used at curves of the pipes. The speciality of this joint is even we can use these types of joints even at the curves of the pipes also. Whereas in the previous joints we have seen everywhere when the pipe is on its the way when they laid on a plane surface. Whereas this joint is more flexible or else more convenient even to join the pipes at the curves also. And also one more characteristic feature of this flexible joint is we can adopt these joints in the water or else in ground or else underwater. These are more suitable. See here, the spherical end of the pipe is kept in the spigot and other of the other pipe. Here, the pipe, the end of the pipe will be kept over here, and this bolt is used to tighten the joint. Once it is tightened, automatically it closes, it moves down, and the joint will be placed, or else the lock will be connected. The rubber gasket is used to withstand the expansion and contract of pipe due to the atmospheric variation. Did you understand? See here, this is the gasket. This is the gasket. The one end of the pipe will be placed into this spigot, and slowly the bolt will be tightened. That means the joint has place. The other end of pipe also kept in the same way so that it won't allow the leakage of water. Understand? See here, this is the bolt. It is the bolt. And here, this is the rubber gasket. The retainer ring. See here, the pipe, end of the pipe will be kept over here. And with this help of bolt, or else with this bolt, the joint will be tightened. In the same way, the other end of the pipe also kept here so that it will continue the flow. Understand? Joint in the sense why we are going for joints? To make the pipes join. That is to join the pipes, will go for joints. This is the bolt to which we can tighten the joint. Next one is victolic joint. Victolic in the sense these are also called as mechanical joints. See here, these are exclusively used to join the pipes made up of wrought iron, steel iron, and cast iron. And the same way we have seen the suitable joints, same all these wrought iron, steel, and cast irons earlier also. What it is? See here, screw joints also used to made up of join the pipes made up of wrought iron, cast iron, galvanized iron. The same way, victolic also. These are the other name is called as mechanical joint here. The flexible joints, the other name is called as bell and socket and universal joints. See here, the groove, see one half of the groove will be kept at one side and half of the groove will be kept the other side. See here, likewise, the joints will be tightened. See, they are also called as mechanical joints. They are used to join the pipes made up of wrought iron, steel, and cast iron. The rubber gasket, it is the rubber gasket, or else rubber ring, U-shaped rubber ring. Gasket is between the two ends of the pipes. Gasket is pressed around the pipe with the bolts of coupling. It can withstand vibration. The same way, the other side of the pipe also maintained. Likewise, the joint will be leak proof. Understand? See here the groove, the first half of the the half of the groove, or else half of the joint, or else the first half of the ectolic joint will be kept at one side. The same structure will continue the other side. See here, these are the pipe ends. See here, rubber gasket ring. The same will be at the other side. When see here, gasket is pressed around the pipe with the bolts of coupling. The gasket is pressed. Gasket is pressed around the pipe so that it will be leak proof. One more time. See here, it is the pipe. The half of the, a groove of the joint will be kept over here, and it is the rubber gasket. The same will be at the other side. See, with the help of this groove, the help of these halves, we can press the pipe so that we can press the pipe in the sense we can hold the pipe tightly in such a way water may not move may not leak from the joint. These are also called as mechanical joints made up of wrought iron. These are used to join the pipes made up of wrought iron, steel, and cast iron. Rubber gasket is kept between the two ends. The rubber gasket where we kept between the two ends of the pipe. The same structure will be the other end. So when we are with the help of bolt, the rubber gasket will be pressed tightly at the pipe at one side and other side, so that the flow will continue and the water will be leak proof. Water may not leak from those joints. And this is the characteristic feature of this joint is it can withstand the vibrations and contractions. The characteristic feature of the previous is it is used to join even at the curves also, and these are used to join the pipes in the water also, in submerged. We can use submerged pipelines, or else at submerged pipelines. These are most favorable or as most suitable joints. See here, these are used, or as these joints are most suitable to the pipelines where we may observe the frequent vibrations and contractions. With the help of rubber ring, we are just pressing on the other two sides so that the joint will continue in such a way it won't go for leakage of water. Understand? This is about the victolic joint. See, up to when we have a look over there, what we have seen, see almost 6 types of joints we have seen: spigot joint, screw joint, collar joint, flanged joint, expansion joint, flexible joint, and victolic joints. Almost 6 or 7 types of joints we have seen. See here, next one is, see one topic we have seen in the previous class: estimation of water demand. Estimation of storage capacity. How can we go? How we can go for estimation of storage capacity? Let us have a look over there where we discuss estimation of storage capacity. We have seen somewhere before groundwater, I think. See here, let us have, see here, this is, we have seen storage capacity of reservoir here. Storage capacity of reservoir we have seen. For that, one formula we adapted. See here, one continuous topic is there, mass curve method. That is what we are going to discuss now here. Mass after joints, the next topic is mass curve method. See here, estimation of storage capacity of reservoir by using mass curve method. See here, one graph we are going to learn on graph. At the end of this topic, we'll go with we'll discuss about the graph. See here, the mass curve method is the cumulative demand curve when it is obtained by continuously adding the hourly demand, which is plotted against the time with respect to hours of the maximum day. See, in one word, it can be estimated with the following formula. What is the formula here? S equal to EP plus ED. What is S? Required storage capacity. EP means maximum excess of supply through pumping. ED, whereas ED is maximum excess of demand. See how we can find out the storage capacity of reservoir. We are going to learn in this method. See here, keep in mind SC equal to EP plus ED, where SC equal required storage, EP is excessive pumping, ED is excess demand. Let us discuss about this method with a classic example. See here, one example is there. You may get the you may get this one problem in your examination, so that you can find, so that by using that particular problem, you must find out the storage capacity of the reservoir. See, have a look. See, example in the sense, let us assume that a problem that you encounter in examination. See, I have just adapted this problem through your textbook. So, for your explanation point of view, once we started offline, we will discuss different exercises. The same the way we discussed about the population forecasting, I just explained about the population forecasting through this online, and the same is practiced in the offlines. Most of the students attended on the day, and they learned different types of population methods with one example on blackboard. In the same way, we may be, when we are allowed to offline classes, we may go for different problems on this storage capacity. For your understanding purpose, now I have taken one problem from your textbook. Now we will discuss on how to solve this problem, where at the end you may get the storage capacity of reservoir. This is what you may get our may get in our examinations. How we can solve, how we can find out the storage capacity from the given data that we are going to discuss now. See here, keep in mind, this we are going to discuss about the storage capacity of reservoir for when the pumping is almost 24 hours of a day. See, this is what about the problem we got in your examinations. Have a look more keenly. Is at 12, from 12 o'clock to 12 o'clock, 24 hours. See, average hourly demand. How much of water is in demand? At 1 a.m., 8,000 liters per minute. At 2 a.m., 9,000 liters per minute. Likewise, the average hourly water demand is increased. See, that means up to, we see, from 12 to 12, we have a data. By using this data, we are going to estimate the storage capacity of reservoir by using mass curve method. See here, before, by taking the given data, how we can go for it? Simply, see here, we have the data 12 to 12. See, what is the data? The below table shows the hourly demand for the maximum day assuming. See, maximum day assuming 24-hour pumping at uniform rate. Determine the storage capacity of equalized reservoir. Reservoir, what will be the uniform pumping? This is about the, see here, problem we got it, and this is the answer, or else how we'll get it, that we'll see. These two columns, they are given. These two columns from the given data. These two columns from the given data. See here, 1 a.m. 8,000, 6 a.m. 15,000, and 6 p.m. 16,500. In the same way, at 11 p.m. 10,000. Right? 11 p.m. 10,000. That means this is the given data we are just trying to solve. See, this is about the average hourly demand. These two columns already they are given. Now, hourly demand. How can we get this hourly demand? Simply, I wrote on point, the hourly demand in liters can be calculated by multiplying it by 60. See here, how we got it? 8,000 into 60, because that is empirical. Why we are going to calculate into 60 in the sense that is empirical formula. See, we must adapt. We won't go how it comes, because we must adapt certain empirical formulas. How we can get the hourly demand? Into 60, 80 into 60, 4,80,000 liters hourly demand. Understand? Average hourly demand liters per minute. Hourly demand, how we got it? See here, 4,80,000. Understand? See here. Now, cumulative demand. See, likewise, 9 into 60. take calcs and do the problem. 8 into 60, that means 48. 9 into 60, 9 6 54. 5 lakhs 54, 5 lakhs 40,000. Understand? Likewise, we are able to find out the hourly demand, the third column. Now you understood how this third column we found, or else how we got this third column from the given data we learned. See, take your calcs and first of all, and find out the values what I mentioned here and compare the value what you got by using calculator. See here, the hourly demand in liters can be calculated by multiplying it by 60. 8 into 60. Likewise, we got the all these values. Understand? Today we learned in this masker method how this third column we got it. And tomorrow we'll continue how we can find out the reservoir storage capacity. If you have any doubts, please make a call to me, the domain, whatever feel convenient. Thank you. Either phone or message or any mail, you can write even mail also. Thank you.